Students, see, in the last video, we studied about physical and chemical properties. Now, see, the next one, do the following activities in group of friends. Take help of your teacher wherever necessary. So, let us see this activity. Apparatus you require is thermometer, evaporating dish, tripod, stand, funnel, Bunsen, burner, etc. So these are the apparatus which we require. Now see, the chemicals required are limestone powder, copper sulfate solution, calcium chloride, potassium chromate, zinc dust, sodium carbonate, phthalic anhydride, etc. Now procedure, carry out the activities 1 to 5 as given below. Read and record the temperatures in the activities 2 to 4. See which are the apparatus you are going to take. You are going to take a thermometer. You are going to take evaporating dish, a tripod, stand, right, funnel, okay, and Bunsen burner you are going to take. See, you can see over here in the figure, okay. See, this is the evaporating dish, okay. This is the tripod, stand. Then you can see the flame over here, okay. So this is the Bunsen burner. So, and you require a thermometer also. You all must have seen a thermometer, okay. Now chemicals, what you require that is limestone powder, then copper sulfate, calcium chloride, potassium chromate, zinc dust, sodium carbonate, phthalic anhydride. Now see, carry out the activities 1 to 5 as given below and read and record the temperatures in the activities 2 to 4. Now see what activities you are going to do. See, take a spoonful of limestone powder in an evaporating dish. Heat it strongly on a high blue flame. So what you are going to do? You are going to take limestone powder. Okay. So you can see over here. Yes, limestone powder is taken there and it is heated strongly. Okay. So see. Now see what observation is seen. If limestone is heated strongly, okay, yes, if it is heated strongly, it breaks down to form calcium oxide and carbon dioxide, okay. So CaO plus CO2. Now calcium oxide is also called as quick lime. It is yellow when hot. So when you heat it strongly, it becomes yellow, but white when cold. So when it is cold, it is white. When you heat it, it becomes yellow. So when we strongly heat limestone, then it decomposes to give slaked lime, that is CaO, and carbon dioxide. See, take a spoonful of limestone powder. Okay. So, limestone powder means what? Calcium carbonate. Okay. So, calcium carbonate, okay, CaCO3, when you heat it, that time, what? When you heat it strongly, what it is going to form? Calcium oxide plus carbon dioxide. Okay. Now, see, that is, you are going to heat this is the sign for heat, okay. Now calcium carbonate, okay, is also white and calcium oxide formed is also white in color. Now the gas liberated over here is carbon dioxide. The temperature change, you are going to supply, you yourself are supplying the heat, isn't it? So there is no temperature change over there. Whatever that is there is increase in temperature, that is because of you, because you are supplying heat, okay. Now see, calcium carbonate, okay, when you heat it, it's giving, this is the reactant, okay. So one reactant is giving you two products, isn't it? Yes, calcium oxide and carbon dioxide. That is AB, okay, is giving A plus B, right? So this we call it as decomposition reaction. Now next one, add zinc dust into the copper sulfate solution. Now what you are going to do, you are going to take some zinc powder, or you can take a zinc metal sheet also, okay, a small one, and you dip it into the copper sulfate solution. Okay, then what change you are going to?
We'll be looking at the displacement reaction of metals. The chemicals that we will need are a beaker of copper 2 sulfate solution, as well as a strip of zinc metal. What do you think will happen if we were to place this piece of zinc into the solution? Let's find out.
See, this blue color solution is copper sulfate solution, and you have dipped zinc into it. So instead of powder, you have taken zinc sheet. Okay. See, observe what is happening.
We observe that as the reaction proceeds, the solution changes from blue to colorless. In addition, a reddish-brown solid also forms on the surface of the zinc metal.
See, blue color has become colorless solution, and there is deposition of reddish color
So
on
what
that
is the chemistry
zinc
behind
metal.
this? Let's take a look.
So why this
This is a
happened?
beaker of copper 2 sulfate solution. The solution is blue due to the presence of the copper ions. What will happen if we add a piece of zinc into the solution?
See, this blue color solution, okay, this solution which you are seeing, which is blue in color, okay, yes, that is copper sulfate solution. So this is copper sulfate solution, and this is zinc metal. So you know, when you are going to dip this zinc metal in copper sulfate solution, after some time, okay, you will see that this solution, this blue color solution, it becomes colorless, okay, and there is deposition of reddish color on this zinc metal. Now why is this? Listen to the explanation.
Let us take a closer look at the reaction. The piece of zinc metal is made up of many zinc atoms, which are packed regularly in layers. If we take a look at the reactivity series of metals, we know that zinc is a more reactive metal than copper. As a result, zinc has a greater tendency to form positive ions. This can be represented using the ionic equation as shown. In forming the zinc ion, zinc metal loses 2 electrons. Thus, we can say that zinc is oxidized. Copper, on the other hand, is a less reactive metal. Thus, it prefers to remain as an atom instead. This can be represented using the ionic equation as shown. The copper ion that is present in the solution takes in the 2 electrons to form copper. Since the copper ion gained 2 electrons, we can say that it is reduced. Over time, as the reaction proceeds, more zinc ions go into the solution and more copper atoms are being deposited onto the surface of the metal strip. As such, We can say that the more reactive zinc metal has displaced copper, the less reactive metal from its salt solution.
Now see, here, this was blue color, right? Yes. Wait. Okay. Now see, this actually was, okay, this was blue in color. Yes. And this was zinc metal. Now you dip the zinc metal sheet into this copper sulfate blue color solution, right? Now what happened was, see, this contained copper CuSO4, right? This is copper sulfate solution. Now this is zinc metal. Now what happened was, the zinc metal being more reactive, okay, than copper, what is going to happen is, in this solution of copper sulfate, this copper is going to be displaced by zinc. Okay, this copper is going to be displaced by zinc. Why? Because zinc is more reactive than copper, hence copper will be replaced by zinc. Okay, and this solution will become colorless. Yes, the solution will become colorless. Okay, and there will be, the copper will get deposited on this zinc metal, and therefore, yes, this the reddish color deposition you will see on the zinc metal sheet. Now see, the more reactive metal, okay, can displace a less reactive metal from its salt solution.
Concept of the reactivity series of metals and how it directly affects the displacement reaction of metals. Over here, we have a beaker of colorless zinc sulfate solution and a strip of reddish-brown copper metal. What do you think will happen if we were to place this piece of copper into the solution? Let's find out. We observe that there is no reaction between copper and zinc sulfate.
Now see, yes, you had, that is, before some time you took copper sulfate and you dipped zinc. Now you're just going to take vice versa, okay? Just the opposite way. Here you have taken the zinc sulfate solution and you have dipped copper, okay, metal sheet in that. Now after 1 hour you are going to observe, okay? You will see that no reaction has taken place. Why do you think so? See, now here this is zinc sulfate, right, solution. Now there we had taken copper sulfate solution, but copper, okay, zinc being more reactive than copper, that is why zinc displaced copper. Okay, now here what is going to happen, you are taking zinc sulfate solution. Now zinc is more reactive than copper, isn't it? So this, okay, so copper is less reactive than zinc, right? Yes, so this copper is cannot replace, okay, zinc in this zinc sulfate solution.
Why is this so? If we take a look at the reactivity series of metals, we know that copper is less reactive than zinc. Thus, both the copper atoms and zinc ions are happy to remain in their original states in this case, and no redox reaction occurs.
Now the next one, add potassium chromate solution to barium sulfate solution. So you are going to add potassium K2CrO4, okay, to barium sulfate solution. So what will happen in this case? Now see, the color of barium chromate precipitate is yellow. Okay, see, the reactants involved in this reaction are potassium chromate and barium sulfate. Okay, see. The reactants involved here are what? Potassium chromate. Okay, yes, potassium chromate and barium sulfate. Now this potassium chromate is yellow in color and is in powdered form. Barium sulfate is white, and when it is mixed in water, it gives a solution which is milky white. So what is going to happen? See, this potassium chromate is yellow. Okay, barium sulfate is white. Okay, yes, see, once again let me tell you, potassium chromate which you have taken. Okay, yes, potassium chromate. Okay, yes, this is yellow in color and it is in the powdered form. Okay, barium sulfate is white in color. Yes, this is yellow, this is white. Okay, yes, so now when you mix it, okay, when you add this potassium chromate in barium sulfate, then what is going to happen? You are going to get milky white solution. Okay, you are going to get milky white solution. The chemical equation involved in this reaction is K2CrO4. Okay, K2CrO4 plus BaSO4 will form BaCrO4. As the potassium chromate salt is yellow when it is added to the milky white solution of barium sulfate, a new compound called barium chromate. So this barium chromate is formed, okay, which is yellow is precipitated. So here a new compound called barium chromate is formed. So see, K2CrO4 plus BaSO4 will form BaCrO4 plus, okay, plus K2SO4, okay, plus K2SO4, that is barium chromate plus potassium sulfate will be formed. So here double displacement reaction has taken place. Now add sodium carbonate solution to the calcium chloride solution. So you are going to add sodium carbonate, okay, Na2CO3 plus CaCl2, sodium carbonate plus calcium chloride. So what will happen when you add the sodium carbonate to calcium chloride solution? We will see. Say calcium chloride plus sodium carbonate, okay, will form calcium carbonate plus sodium chloride, okay, CaCO3 plus NaCl. So you know this what has taken place over here, instead of chlorine carbonate has come here, CO3, and Na, yes, the Cl2 has come in place of carbonate, right? Yes, so that is why we call this as double displacement reaction. Now see, calcium's valency will come to, okay, carbonate, and carbonate's valency will go to calcium, and here also NaCl. See what you're going to do here. You're going to take phthalic anhydride. You're going to take it in an evaporating dish. Then you're going to close the end of the stem of a funnel with a cotton plug. You're going to take a funnel, okay, and the stem of the funnel is there. Now you're going to close it with cotton plug. Now you're going to keep this funnel inverted on the evaporating dish. Heat the evaporating dish on a tripod stand slowly on a low flame. So now you are going to heat this phthalic anhydride. So what you are going to observe in the funnel during heating? See, this is phthalic anhydride. Okay, C8H4O3. Now see, C8H4O3. This is phthalic anhydride. So in presence of oxygen, you are going to heat it. So what is going to happen? It's going to get converted into carbon dioxide and water. So here only physical change is there. There is no chemical change. Okay. And gas has been liberated. You can see carbon dioxide gas has been liberated in this case. See, I have explained to you all these activities. Now record your observations, okay, in this table and complete the following table. Now find out, observe and keep a record of the physical and chemical changes that you experience in your daily life. So you can observe, you know what is physical change and what is chemical change, isn't it? So you can record some of the physical and chemical changes that you are experiencing in your daily life. A physical change takes place due to change in the parameters such as temperature, pressure. Often a physical change is reversible. Okay, most of the time, you know, this physical change which is there, it is reversible change. Just like how I told you, ice can be converted into water, water into gas, again gas can be, that is water into vapors, and again vapors can be converted into water, water can be converted into ice. So this is reversible change, isn't it? So usually the physical changes which are there, those are reversible, and this physical change, okay, it takes place in the parameter, that is the changes which are there, it is taking place in the case of temperature and pressure. The composition of matter remains the same in a physical change. So the composition which is there, that is going to remain same. For example, ice is transformed into water on heating and water is transformed into ice on cooling. On the contrary, if the composition of matter changes during the process, then it is called a chemical change. So we have studied this, isn't it? In most of the examples above, that see, if the composition change, then it is chemical change, but in case of physical change, the composition is going to remain same. When we call a particular process or phenomenon as a chemical change, some chemical reactions are taking place in the concerned matter. A chemical reaction is a process in which some substances undergo bond breaking and are transformed into new substances by formation of new bonds. Now, you know, when a chemical reaction takes place, sometimes, you know, some substances, they undergo bond breaking, that is, there is breakage between the bonds in them, and sometimes what happens, there is formation of new bonds. So sometimes bond breaking takes place and sometimes formation of new bonds also takes place during this chemical reaction. The substances taking part in chemical reactions are called reactants, whereas substances formed as a result of a chemical reaction by formation of new bonds are called as products. So the substances which are taking part in the reaction, okay, they are called as what? Reactants. And those, that is after the reaction, whichever substance has been formed, that is called as what? Products. For example, formation of carbon dioxide gas by combustion of coal in air is a chemical reaction. So carbon plus oxygen, okay, forms carbon dioxide. So here carbon and oxygen are taking part in the reaction, isn't it? So this carbon and oxygen are the reactants, and after combining with each other, carbon and oxygen, what it has formed? It has formed carbon dioxide. So this carbon dioxide Okay, this is the product. A chemical reaction is represented by writing a chemical equation. Now see, let us study this chemical equation, how to write the chemical equation in detail. We'll study it in the next video.